Hello, my name is Stephen Chen. I'm VP of Developer Relations at JFrog. And today I'm going to talk about the Singularity, which is here and whether your deployments are ready for this or not. So first of all, let's talk a little bit about the Singularity and what the criteria is for it actually occurring. So this has been a popular topic of science and of science fiction, because as we see the acceleration of humanity's evolution, and in particular in recent years with the growth of computational power, there's been an exponential increase in the amount of processing power available to computers, and at some point the processing power of computers is going to surpass that of animals, of humans, and eventually that of the entire human species, of humanity's combined intellect. So when you look at this, it's obvious that this is going to occur with the rate of evolution in recent years. Moore's law basically shows that we're advancing at a pace where this is going to occur very quickly. And the question is, what are the criteria? How do we know when this actually is going to occur? So I think there's a few key criteria for us to hit the Singularity. The first one is having a large enough data pool in order to model and simulate the entire world. So if you just look at humans, there's 7.2 billion humans, 6.2 billion nucleotides, 1 times 10 to the 19th bytes. And this is something which in the digital world we already have enough storage to hold. We have 6.8 times 10 to the 21st bytes, or essentially 6.8 exabytes. So given the huge amount of storage we have, we can actually store the genetic information of the entire human population. If you look at the Earth, storing all the genetic information for the planet, we're not quite there. That's 1.325 times 10 to the 37th power to store all of the data in the world. But we're getting there. So I think pretty soon the humans will know more about the world than we will. The next question is, when we hit the exponential rate of technology advancement required for computers to become smarter than humans. So if you look at the tensor processing units that Google's putting into production, an array of those of TPU version 4s already gets you 1 exabyte of processing power. So we're basically almost there on computational power today. When you look at quantum computing, IBM's been greatly increasing the number of qubits in their quantum computers. It's up from 50 only a few years ago up to 127 in the one which they're working on now. So quantum computing, which is again something which is going to be necessary for AI to surpass human intelligence and to continue Moore's law, is something else which is also advancing very quickly, and will start solving NP-complete problems, cryptographic problems, and all sorts of science and challenging computational problems that modern processors are not suitable for. And the last step is, when do we get full automation of technology? And I think we already have this to a degree where you see 3D printers can now 3D print themselves. So this is a 3D printer which is 95% 3D printed. It can self-replicate and build another 3D printer like itself. And this is what the robots will need when they create armies of robots to come out and to start conquering the world. So I think we're getting very close to the conditions for the Singularity when you look at all of these put together. And all of this has actually been predicted before. So let's take a trip back in time to what we already know about the future.
In the 21st century, a weapon will be invented like no other. This weapon will be powerful, versatile, and indestructible. It can't be reasoned with. It can't be bargained with. It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
Okay, so clearly Arnold had it right. The future is all about the machines, and that's what is happening now as you look at the computational growth. So when is this actually going to occur? And there's a simple model for this as well, which is plotting the intelligence of humanity, plotting the machine intelligence, and seeing when the machines actually pass the combined intelligence of humanity, which as you can see, is gradually going up, but not as quickly as machines. Although, I think there's something wrong with this graph, and I have human intelligence going up, but especially in the past couple of years, I think this is probably erroneous. So we're gonna do a slightly downward plot to more accurately reflect what we actually see happening in the world. And I think we're quickly on the trajectory where the machines are going to overtake, and they're going to become smarter than us, and maybe even as soon as the year 2040. So again, through the great advances in technology from the JFrog team, we were able to put together a time machine similar to what they used in the Terminator, where you put in the current date, you put in your target date, and then we can travel into the future and see what it looks like in the year 2040. So let's take a quick look into the future and look at, here's the future of television. Apparently it's a bit of a regression, but I think it's an improvement over all these silly flat or curved screens. This was the right curve, of course. And it looks like the United Nations has recognized the first autonomous serverless life form. So now we have autonomous life forms in the cloud. They're probably using digital currency to buy more cloud credits to self-propagate and solving hard computational problems in order to mine and to get more credits and currency to grow. And now we're actually recognizing them as autonomous, which is awesome. So the humans are starting to embrace their new robot overlords. So it's a good first step. Let's see what's in the news. Okay, so it looks like finally the airline industry is always a little bit behind. We're getting continuous deployments to airplanes while they're flying. So this is truly over-the-air updates, where we can actually update software in planes. We can patch zero-day vulnerabilities while planes are flying around, and then block terrorist hacks or other attempts to interfere with air travel. So this is awesome. And look, here we have a billboard about crop computing. So I think we've progressed past cloud computing, and we've gone towards something that's much more profitable, which is corn computing. And we've been able to greatly expand the amount of devices which can be used on the network. So this one isn't that far away from reality, actually, because there's already more than 30 billion IoT devices predicted to be online by the year 2025. So we are already coming close onto this. And one of the classes of devices is actually used for agriculture to do monitoring of moisture, temperature, other sensors to increase crop yields. So farmers already are driving the revolution. And in order to power this, we need to be able to deploy modern software as quickly as possible to all of these devices at the edge. Now the problem here with this continuous deployment is not the machines. The machines are incredibly efficient. They are able to deploy quickly and rapidly, do quality checks, do everything automated, and can keep a continuous flow through the system. It's the humans which act as bottlenecks, where we're slow, we need time to process things, we make mistakes, which further slows things down. And I think the robot's not going to be smiling for very long when he realizes that the human at the end of the line has a small water bucket capacity for what can actually go through the system. So it doesn't matter how fast the robots are working. It's the human which is the real bottleneck in the system. So if we want to please our new robot overlords, we need to get a little better than this and start automating our system. So our goal here is to figure out how can we better automate our DevOps pipeline in order to have end-to-end improvement in our throughput. So the first step is having a good continuous integration strategy. So from source control, you want to be building in automated fashion using a CI server, such as Jenkins or Tekton or Spinnaker or any of the other great CD Foundation projects. Then you want to push your releases into an artifact management system like Artifactory, and use this as either a container registry or a release staging point to push into integration, system testing, staging, and production. And at each of these measures, you implement automated quality gates, which are only allow you to releases to propagate to the next step if you're actually passing all those criteria. And it could be running tests at different phases, doing security checks. It can also be for performance tests as you get farther down the line with staging environments which are very close to production. And also can help you with rollbacks if you need to roll back to an earlier version because you hit into a production issue. So if you have all this automated with quality checks, with good continuous integration, continuous deployment, you're using cloud native technologies like Kubernetes to deploy to, then you can make a very automated end-to-end system which will get rid of humans as the bottleneck. So once you've gotten rid of humans as a bottleneck in your continuous integration and continuous delivery system, the next question is, how can you do this for security as well? And the problem with security is that when you're developing software, it's very easy to fix security vulnerabilities. As you get into testing, staging, and to production, any security issues which are caught in production, and especially security issues which impact your customers or which cause vulnerabilities in the wild, are going to be very expensive and costly to fix. Whereas if you can catch them earlier in the process, this is a significant cost savings and improvement in your overall process. So the goal here is to shift processes like security, like observability, production issues, as far left as possible so that developers can identify them and can fix them as early as possible. This both reduces the costs for fixing security vulnerabilities, and it also reduces the amount of time spent on it, and ultimately your time to market and your exposure to your end users. So if you can shift security left, you get cost savings, and you also get increased security for your entire DevOps pipeline. So now we've automated our pipeline, we've secured our pipeline, and the next step is how we're going to observe our production instances with end-to-end traceability. So we now set SwampUp end-to-end visibility from code all the way through to production using the JFrog platform and collaboration with a bunch of our partners. So we have integrations with Jira, Slack, and Microsoft Teams for collaboration between development and operations. We have integrations with different observability systems like Datadog, Splunk, Dynatrace, and Elastic, so you can easily observe, monitor, log, and trace your production instances to quickly identify when there's issues and to more quickly respond to this. And we also have integration with ITSM products like PagerDuty, which allow you to do better incidents and change management. And all of this is tied together so that you have a seamless workflow. When you identify a production issue, you can directly open a Jira ticket, you can get your teams working on it and notify them via Slack, and you can do production deployments from a single pane of glass is the vision here. So this end-to-end platform, which allows you to store your packages, do security of your packages, distribute packages to the edge, and do integrations with collaboration, ITSM, and observability is the JFrog platform, of course. So this gives you an end-to-end visibility across your entire DevOps pipeline, and it will help you to be faster, more efficient, and to better serve the needs of automating your pipeline and integrating with the robots as they start to take over things after the singularity occurs. So now if you look at the situation, originally it was a lot of people pushing machines and processes. What we've done is through automation, through shifting things left, through better end-to-end integration, now the machines are doing the majority of the work. So we've freed the machines to be more efficient, and the humans are only involved with intervention. And with technologies like AI ops, where now we can actually do better inspection of logs and only alert people when there's really strong, really critical issues, then you can have one operator who's looking at a large cluster of machines and efficiently maintaining and only dealing with exceptions. So we basically reverse the man-machine ratio from one machine with lots of people maintaining it to lots of machines with one machine maintaining it, which is hopefully you and me coexisting with the machines in a more efficient world. And speaking of a more efficient world, I think the first step towards building a more efficient world is empowering the next generation of developers and DevOps engineers, which is our kids and other folks who are going to school. So something else which I like doing is teaching kids workshops with robots like the Now robot, which is a great way to teach kids to get them familiar with their new robot overlords before they start calling the shots. And it's a great way for us to build and get kids interested in technology at a very young age, when they can start learning things and can build more interactions that'll help them to build better technology and to advance things. So hopefully you learned a little bit about DevOps pipelines in this presentation, how you can be more efficient and improve your processes, and also how you can coexist with robots when the singularity occurs by being more efficient in your DevOps pipelines, and also by teaching the next generation of developers to coexist with robots. So thank you very much for having me, and I hope you enjoy the rest of the conference.